Hello and welcome. Today we will explore the mathematical concept of percentage change. Specifically, we will discuss how a number x, when increased or decreased by a certain percentage y, the result is the resulted value or the new value is calculated either as 100 plus y times x divided by 100 when it is increased by y percent, or as 100 minus y times x divided by 100 when it is decreased by y percentage. This formula is fundamental and it is applicable in various real-world applications, from computing price discounts to analyzing population growth. Let's just focus on the core concept. We have a given number x and we want to understand or we want to calculate new value when it is increased by y percentage. So here, in case when it is increased by y percentage, the new value is given as 100 plus y times x divided by 100. And similarly, when it is decreased, when x is decreased by y percentage, the new value becomes 100 minus y multiplied by x divided by 100. This method is widely used because it offers simple yet robust way to adjust value based on the percentage change. Now let's rewrite these formulas step by step. So let the original number be x, and what we want to do is we want to increase it by y percentage. So that means we want to add y percentage of x to x. So that means x plus y percentage, that means y divided by 100. And what it is a percentage of what? It is percentage of x. So y by 100 multiplied by x. Now, if you observe, x is common over here. So we can take x out of the out and write this particular expression as x times 1 plus y by 100, and which can be further simplified as 100 plus y multiplied by x divided by 100. Similarly, when the x is decreased by y percentage, we have to subtract y percentage of x from x. That means x minus y by 100 multiplied by x. So this particular quantity is representing y percentage of x. And since we are decreasing, we are subtracting it. Okay. So this particular expression, we can observe x is common in both the terms. So we take that out and rewrite this particular expression as x into 1 minus y by 100, the bracket closed, which is further simplified as 100 minus x, 100 minus y multiplied by x divided by 100. So moving on, so we looked at how do we calculate the final value or the new value when x is either increased or decreased by y percentage. So where this is useful? Let's understand that where it is applicable in a real world applications. So suppose you want to calculate the price discount. Imagine a product originally priced at X and a discount of Y percentage is applied. And you want to know, okay, if I have to buy that particular product, what will be the price after a discount? So in this case, what we'll do, since it is a discount, we will subtract Y percentage, right? That means the final value will be lesser than the initial value. So in that case, we will use the formula where we are decreasing value by y percentage. The second case, the population growth. So in demographic studies, a population might increase or decrease by percentage annually. So the same formula applies. If it is growth, we say x, we will use the formula 100 plus y multiplied by x by 100. If it is decrease in the population, we'll use the other formula, that is 100 minus y multiplied by x divided by 100. And then the financial calculation, suppose we have simple interest calculation, then when we are dealing with interest rate and investment, this percentage change formula will help us to identify what will be the final amount that has to be repaid or that has to be paid for that particular. So first you have taken a loan. In that case, you will have to the final amount that has to be paid by you to the bank will be 100 plus y multiplied by x divided by 100, and that I mean that's how the final value will look like, and that is where this formula will be useful. Okay, now this formula is broadly applicable. It's important to be aware of several precautions. We don't have to make a mistake, although we should be mindful about making some mistakes. So we have to interpret the percentage correctly to ensure that percentage values that are used correctly. And for instance, a 20% increase should be represented by the numeral 20 in the formula in 9.2. Rounding of errors. So in financial calculation, even slight rounding of errors or rounding of differences can lead to significant discrepancies. So precision is a key. Contextual application. The formula assumes a linear relationship. So in more complex scenarios such as compound interest, and additional considerations are needed. So that compound interest we can discuss some other time. But for the simple interest calculation, you can use this formula. Uh, and the final one, the dominant consideration. So verify that the value of x and y makes sense within the context of the problem. In some cases, certain restrictions or boundary conditions might apply. To summarize our discussion, we started with the formula for percentage increase and decrease. We derived the formula, then we explored the applications, real world applications, including price discount, population growth, and financial interest calculation. And then we discussed important precautions such as correct interpreting percentage, handling rounding of errors, etc. So understanding these formulas not only reinforces your mathematical skills, but also equips you with a powerful tool for analyzing everyday problems. So I hope this video has provided you with a clear explanation of the concept. Thank you for watching, and I encourage you to explore further applications. And if you have any questions, please make a comment. I will be glad to answer those questions. Have a great day.